welcome to today's class. Today we are going to look at, or we are going to continue our previous class, which is naming of organic compound. We did naming of alkane compound, and today we are going to look at naming of alkene and alkyne. But before we do that, let's take a little recap or revision on how to name organic compound. I'll make mention of the rules using the IUPAC nomenclature, IUPAC system of naming organic compound. And I say number one, we must consider the functional group and the parent chain, the parent's name, and we must do the numbering both left and right, and we give the least numbering to what the substitution attached to the carbon atom. I also mentioned that we're also going to give the least numbering to the functional group in case of carbon atoms or carbon compound with functional group like the alkanol or the alkanoic compound. So we give the least numbering to the functional group. All right, so let's see what we are going to do today. We are going to name these two major compounds. We're going to look at the alkene and alkyne. All right, the major difference between the two of them is just their physical difference is just that they are bond. Like this one possess double bond and this one possess what? Triple bond. They are both what? Unsaturated hydrocarbon. Okay, let's take a look at this. In example, we have this compound. Remember from what I said that each carbon atom is entitled to only 4 bonds. So that means before, when you are drawing the structure, you must make sure you count your bond. Is it up to 4 or more than 4? Like example, we have 1, 2, 3, 4. So this is okay. 1, 2, 3, 4. So this is okay. So there will be nothing here. If we have carbon atom, hydrogen atom here, that means we have this side to be empty because these two carbon atoms already occupied. Then the next thing we must consider before naming this compound is the position of the double bond, because it gives us a perfect naming in the IUPAC system. Looking at this, we have carbon atom 1, 2, 3, 4. That means you are looking at butene. Right now, since the double bond, we are looking at what? Butene. All right, but the next thing we must consider the position of the what? The double bond, where it is. Now this is position number 1, position number 2. Okay, also counting from this side, position number 1, position number 2. So that means this will be what? Butene. All right, so this is the perfect naming or using the IUPAC system. What if we have other complex compound that may be more complicated than this? Like example, the position of the double bond is not at the first one. Like example, we have this. Then here we have this, and here we have this. All right, so what do we do in naming this? We are looking at two things. First, we have the double bond. We are going to give the least numbering to the what? To the double bond. That means if you are counting 1, 2, 3, here will be at carbon atom number 3. So we are not going to count from there because that is not the least numbering. From this side is 1, 2. So that is the least numbering. And also, if we count from here, we discover that this chlorine attached to this to the compound will be at the 5th carbon atom, and that will be a very high numbering. So for a confirmed or correct IUPAC naming system, we have to give the least numbering to both the double bond and also what? The substituent. But we also have the bromine here. So what do? If we count from here, bromine will be at the third carbon atom. If we count from here, bromine will be at the what? The third carbon atom. So what do? Alright, first and foremost, give the least numbering to the what? To the bond, double bond. Alright, so cutting from here, first we count what compound are we looking at? This 1, 2, 3, 4, 5. So we're looking at what? Pentene. Since we have a double bond, we are looking at what? Pentene. Alright, the next thing we are going to look at is the position of the what? The double bond. We have 1, 2. So we are looking at what? Pent 2 in. Alright, so the next thing we consider again, since we are counting from here to give pent 2 in, that means we're also going to name it from this direction. That means you're going to look at, this will be 1 chloro, this will be 1 chloro, 3 bromo, but naming in alphabetical order. So this will be what? 3 bromo, 1 chloro, pent 2 in. Alright, as simple as that. Okay, let's take another example for the alkyne family. The alkyne family, what you must know that they possess a double bond. Alright, before we get to alkyne family, let's look at the geometric isomers. The geometric isomers of the alkene. The geometric isomers of the alkene, we have the cis and trans. Alright, so if we have the double bond position in this format, let's say this is chlorine position here, and this is chlorine. Alright, this is 1, 2, 3. So we see have other option. Alright, so in naming this is 1, 2. Alright, so this will be 1, 2 dichloro. What are we looking at? This is carbon atom 2, so we are looking at what? 18. 1, 2 dichloro what? 18. But since we are considering this to be a what? An isomer of this compound. So looking at this, the attachment is being attached in the same plane. So this will be what? Cis. So we are going to name it what? Cis. So this will be what? Cis 1, 2 dichloro what? 18. Are we good? Or we can name it cis 1, 2 dichloro 1 in. Are we good? Alright. So let's take example in the case of the trans format. We have this. When the substituent is being attached in the opposite direction, we call this what? The trans. If you look at these two, the two compounds, they are just the same, but the difference between them is they are what? They are what? Isomers of each other. Alright. So look at this, the chlorine and the chlorine are in what? In trans form of it. Alright, so this will be what? Trans 1, 2 dichloro 18. Alright, it's as simple as that. Alright, let's take another example. If we have All right, let's look at this compound. Look at this. It's as simple as any other thing, but can be a little bit complicated. What we must consider, let's look for our compound, our bond are complete. This is 2, so we can have hydrogen atom here. This is 1, 2, 3, so we can have a hydrogen atom here. This is 1, 2 plus 2 hydrogen, so that's okay. This is 1 plus 3, that is 4, 4, 4. Okay, this is correct, so this is okay. So how do we name this compound? First, remember what I said earlier, we must count the longest continuous chain. All right, to count the longest continuous chain, we are going to count it in both every direction just to get the longest. All right, let's start. Let's start from the top. This is 1, 2, 3, 4, 5, 6, 7. So we are looking at what? Heptene. All right, it's as simple as that. All right, let's count from the other direction. From the other direction, we are going to have 1, 2, 3, 4, 5, 6, 7. Okay, we are seeing having 7 in this direction. Okay, let's count this direction. 1, 2, 3, 4, 5, 6, 7. All right, still 7. Let's count this other direction. 1, 2, 3, 4, 5, 6. Okay, this one is not even up to 7. So we are going to take the longest continuous chain. Now, almost 3 direction gave us carbon atom number 7. But what do we consider next? The position of the double bond, so that we can give the least numbering. Therefore, we are going to either count from this side or this side, because if we count from here, we are going to look at what? 2 in. Are we good? All right, so counting from this direction, so we're looking at 1, 2, 3, 4, 5, 6, 7. All right, so we are counting from this direction. That means every other chain attached to it are what? Substituents. All right, okay, so for we to name it, we're going to determine how many substituents that has been attached to it. Where we have 1 here, this is 1 methyl, this is 2 methyl, and this is 5 methyl, that is 2,5-dimethyl. All right, so we have another one here. This is what? Ethyl. So this will be what? Naming alphabetical order, ethyl will come before what? Methyl. So we start from the ethyl. So this will be 3 ethyl, 2 5-dimethyl, 2,5-dimethyl. We're looking at what? 7 carbon atom, which is what? Hept2 in. Because of the position of the what? The double bond. That is why we're having 2 in. The 2 here indicate the position of the double bond. If it was here, it would be just heptene or hept1 in. But since it is at the second carbon atom, we need to put it or include it in our naming. That is the IUPAC system of what? Naming organic compound. All right, this was very cool. Just go through it and look at it very well and don't get confused. All right, the next thing we are going to consider again, let's look at the double bond. That is the what? The alkyne. All right, if we have this, look at what we have here. This is 1 plus this 3, that is 4, plus this 3, that is 4. So these 2 are okay. So we can have chlorine here, we can have bromine here. I put here CH3, I close this aspect, and I put here CH3. This other side is closed, nothing more. All right, I put here chlorine again. This side is closed, I close with here. All right, looking at this compound, it's a little bit complex and a little bit simple of more. The next, what we are going to look at first is for we to count the longest continuous chain to get the parent's name, which is 1, 2, 3, 4, 5, 6. All right, so we are looking at what? Hexyne. All right, hexyne. All right, the next thing we are going to look at is what? The attachment of the what? The substituents. Okay, second, let's look at where the triple bond is positioned. that is a multiple bond. And look now, 1 2 3. All right, 1 2 3. All right, so it's at the middle, so anywhere goes. All right, but let's see, counting from here, if we are naming from here, so we are going to be having 2 2 5. That is the position of this 2 5 2 5. All right, naming in alphabetical order because we have the bromine here, so this will be 2 bromo, 2 5 2 5 dichloro, 5 methyl hex 3 ine. All right, so this is 2 bromo, that is the bromine is at the second carbon atom. 2 5, that is the chlorine, is at the second carbon atom, also the 5th carbon atom. Now the chlorine is multiple, so we use the prefix of what? Dichloro. That will be 2 5 dichloro, 5 methyl hex 3 ine. Hex 3 ine simply means that the triple bond is at the 3rd carbon atom, the position number 3. Okay, the YNE, that is a suffix name. We give it the parent's name. Is telling us that you are dealing with what? Alkyne. That is a triple bond, which is what? Unsaturated what? Hydrocarbon. All right, let's take another example to end the class for today. Let's take a simple example again. Let's peradventure we have this. How do we name this? If we name from here, this will be what? 1 2. So this may be 1 bromo, 2 chloroethine. All right, 1 bromo, that is your naming from here. 2 chloroethine. And what you must consider again is that we are giving the list numbering to the what? To the substituent, and also to the what? The functional group, sorry, the triple bond that is here with us as the what? The functional group, because it determines the parent's name. All right, so thank you. We are going to continue in our next class to maybe solve other questions, and also how to interpret from structure to names. Like example, I'm going to give you a structure and I ask you to give me the name. How do we do that? So we are going to look into that in our next class. So stay tuned with us. Make sure you subscribe, turn on notification bell so that you get notification when the next video drops. Thank you.